outside the box. I'm not trained for circles. So box is square or something like that, rectangle. So when it comes to circle, he doesn't know how to think. So this is not the culture of thinking that is going to survive in the era of IR 4.0. Okay. So as I mentioned just now, a lot of worry. People that I talk to, robots taking over human jobs. You see a lot of manufacturing industries are employing robots. So, and the study shows by 2030, which is not long, from now, only 12 years from now, intelligent agents and robots could eliminate as much as 30% of the world's human labor. 30%. That's a lot. A lot of jobs are going to be taken over by robots. Okay? And we have automation that's going to displace about 400 to 800 million jobs by 2030. And this makes 375 million people to switch job. To switch job. Because they are not needed in their workplace, they have to find new jobs entirely. And this basically is a major challenge of jobs being replaced by automation, by robots. Even in the 1960s, President Kennedy was already very, very worried about maintaining the full employment at a time when automation is replacing the man. During that time, it was automation. But now we are working on Industrial Revolution 4.0. We have intelligent robots, more intelligent than humans, and can take over some of the humans' jobs that are available in the market right now. Okay, in the past, if you talk about doing buat baju, making clothes. So they use all these spindles and things like that, very manually. Okay, and during the Industrial Revolution, the task of weaving process to make the clothes was automated. So this is the some of the machines that was available very long time ago. And the workers operate the machine, make sure maintenance and things like that. So this automation actually increased the production. Previously, a single weaver can weave in an hour. With the machine, it has increased by a factor of 50 for a single weaver. So imagine if you have 10 weavers, it's a factor of 500. The speed of weaving. And the labor required fell by 98%. When I showed you about 2030 was just 30%. This is 98% in the industries. It was hell break loose. Everybody was very worried. But you see, the clothes becomes cheaper because it is faster to weave. And there are more demands. People are more trendy. People want more clothes. Instead of having 10 clothes, maybe they want hundreds. So more demands, and jobs for the weavers quadruple between 1830 to 1900. So instead of the jobs lost, actually the job is increased because of the increase of demands. So and this is the modern industry of the weaving industry. So basically, the technology changed the nature of the weaver's job. No longer weaving, but mainly looking at the machines, operating the machines, and so on. So the skills are different. Okay, so it is not like you are going to lose job, but you are going to tailor your skills towards the Industrial Revolution. In our case, Industrial Revolution 4.0. No longer is education or information that you receive or the skills that you're going to acquire or maybe learn is the same. So you need to align yourself to the industrial revolution, the skills that are required. Okay, when we talk about Industrial Revolution 4.0 in the manufacturing sense, it's about customization and variations. Maybe today, Siemens has about 18 product variations. But in the future, they may have 56,000. So it is about customization. It's about variation. Because of the informations you have about your customer, yeah, and you have a lot of data to learn about the preference of the customer, so you can produce different types of variations so that the customer will be very, very happy with your product because they can buy the product that they want, yeah? Not the product that others buy, but what they prefer. Okay, and basically the difference between Industry 4.0 and 3.0 is about, as I mentioned, customization versus mass production. So probably the left-hand side shows about 3.0, you produce the same flavor, the same product, but in the era of IR 4.0, you can vary the flavor. Okay. I'm going to skip this video because time is not with me. In Cairo, we are also establishing what is called a smart manufacturing laboratory. So we are going to have IoT with all the CNC machines and the robots, and also the drones flying around, you know, so if you have time to go to KL, maybe next year, you can come and visit Cairo and see the smart manufacturing lab. This is the scenario of the manufacturing lab that we are going to have in Cairo. Basically, it's going to be ready by February next year. We have IoT structure. And we also have robot assembly module, and we have CNC 3D printing, and then drones to deliver all the products from one place to another. Okay. I'm going to show this video. This is a good video to show about... Oops.
Industry of Things is moving into production, and manufacturing will change industry in the long term. Everything is networked in the factory of the future. Machines, robots and people communicate digitally. The fourth industrial revolution is still in its infancy. It needs many steps to implement the vision. Artificial intelligence is the precondition.
Die Mehrwerte, die wir heutzutage sehen.
The benefits we see today are those that come through the subfield of artificial intelligence, machine learning. And machine learning means that we have software algorithms that learn from data. And the most important thing at this point is actually the data. Unfortunately, in many cases, we do not have enough. It is also very difficult to gather them. And for this, it is simply important to create standards in order to obtain this data at all and to allow new applications.
Überhaupt diese Daten zu erhalten und neue Anwendungen zu ermöglichen.
Automatica 2018 shows what new applications look like when real production worlds provide virtual data for further processing. FANUC, for example, connects 68 machines and robots to each other on their stand. Production can therefore be tracked in real time, providing transparency and predictive maintenance before machines fail. The company Team Technic is also focusing on making the individual components of a factory smarter. These data are collected with a special software, standardized, securely and efficiently. Ultimately, data collection and analysis of data is used to improve my product quality, identify weak spots, and then to correct and improve. And today I just need a tool that supports me. Not to have to do everything manually, but a tool that will take my work off of me. It takes a lot of time to carry out such analyses manually. We can supply, prepare and make available all the information in advance. In order to avoid error sources, Siemens also relies on digitization, more precisely on the digital twin of a real machine. With it, changes in the production process can be simulated and tested in advance. You want to import a software update into your machine. You want to make optimizations on your machine, make changes, insert new components. That means I have to carry out an engineering, so I need to shut down the machine. I have to import my software, I have to test it, and the whole time the machine is at a standstill. It cannot produce. But the end customer's goal is basically the machine has to be running, it has to produce. And how can I shorten these downtimes? I take the digital twin, I test my optimization work in advance at my office desk, and only when I'm sure that what I want to import into the machine, that it actually works, only then do I go to the customer, and these downtimes are significantly reduced. To make the production process flexible and easier, manufacturers are increasingly relying on artificial intelligence. One of the aims of this is to make robots more easily programmable in the future, and to have them learn independently via image recognition, for example, for sorting processes. One must provide it once with a large data set of images telling it this is an object A, B or C. The neural network, which works a bit similar to the human brain, can now recognize the objects independently, and the objects can also occur in different layers. The neural network of the robot learns by itself. This section of machine learning is called deep learning. Automatica 2018 is the platform to discover the world of tomorrow, from robotics and automation to smart components and digital data analysis.
Okay, that was a very good video that shows about the technology, current technology in some of the factories, and also the future that it will bring. Yeah. So some notes that we can gather from the video: the manufacturing industries looking into IR 4.0 to be networked digitally. Yeah, using the IoT technology. IoT is simply the communication platform, yeah, to gather all the data from all the machines together. And AI and machine learning are really a preconditions in any of the smart manufacturing systems. Yeah. And you can, using all this infrastructure, the IoT, and also using the AI technology, you can track all the manufacturing process, and you can do predictive maintenance. You can forecast the health of the machines so that you can reduce the impact of the breakdown of the machine, so you can reduce the cost of maintenance. And then you can use the informations for data decision making. And robot definitely can be made more intelligent and programmable by using the vision system, image processing techniques. Robot can do sorting. Robots can identify objects very, very easily. Okay, so and central to the AI technology is of course neural network, and now there is a new kind of neural network or extended version of neural network, which is called deep learning. Yeah. Okay. All right. When we talk about IR for Industrial Revolution 4.0, we look at industries. I just want to share with you because I'm very passionate about what Japan is doing. Instead of looking at Industrial Revolution 4.0, they look at what is called Society 5.0, because Society 5.0 doesn't look just at industries, but it looks at other aspects of the our lives. Our lives. For example, agriculture. For example, medical, healthcare and medicine. And it looks into information or well-being of the society. So Society 5.0 is what Japan is now doing. It is more like a human-centered society that actually balance the economic advancement with the resolution of social problems by systems that highly integrate cyberspace and physical. It is using the technology of IR 4.0, but it is implemented not just to the industries, but also to other aspects of our life. Yeah, that is more wholesome, in my opinion. Yeah. So society 5.0, as is shown here, looking into the social of the human being and old people, the medical care, and so on. So this is something that is, I think, we can reflect on the technology that we have. Probably we can use it for better use than just for industries. Yeah. Industry is very important also for the economic development of our country, but I think at the same time the society is also very important. So sometimes we can have a balance, yeah, between the technology for the industries and also the technology for the society. So I'm going to skip this because it's almost the same as this. One of the things that is very impactful, the Industrial Revolution 4.0 technologies, AI, machine learning, robotics, and so on, is on precision medicine. So precision medicine, a lot of words here, but I'm just trying to put it in layman term, is a medicine that is prescribed to you because of you. Yeah, because of your medical history. Not prescribed to you because it's being prescribed to everybody that has that kind of medical condition. So it is customized, not customized, customized prescription. Yeah, the medicine is not customized just for you, but the prescription is customized just for you. That is what is called precision medicine. So it takes into account, because of the data that we have on each and every one of the patients, so you can see the variations of each individuals in terms of dia punya genetic, in terms of dia punya environment, lifestyle, and so on. So these are the elements of precision medicine: the medicine itself, the tools, and data science. And this is some differences. If I just look at maybe the item on treatment. I have a lot of things to cover. I'm just going to go very fast here. So nowadays, one treatment fits all. Okay, so this leads to various kinds of results. Sometimes people have sort of cannot take that kind of, it causes a lot of side effects for some person and so on. But in precision medicine, because of the availability of historical data and the AI techniques that is going to study about you, your condition, your historical conditions, and so on, and can make decisions on precise medical medicine that should be prescribed to you. So each and every one of you will have a different medicine, even though you have the same symptom, and so on. So this is what precision medicine is, and the beauty of having AI technology in order to go for precision medicine. Okay. Again, about personalization, which is the technology of AI can do. Everybody knows Netflix, right? Everybody use Netflix. Yeah. And sometimes you wonder how they know that we have watched this movie, watched this drama, and so on. Yeah. So this is what AI can do. Yeah, it can give you, it can store the information, the historical data. It can give you suggestions since you have watched this movie before or this drama before. They will give suggestions. Yeah, similar drama for you to watch. Yeah, similar series for you to watch. So you'll be staying at the TV all the time lah. Okay. So actually Netflix made a lot of money because of these personalized recommendations. I like Netflix because I feel that Netflix cares for me, because Netflix knows what I like and not like and things like that. So that is what a lot of people like, yeah, because it's like you are being treated, personally treated. So actually Netflix saves about 1 billion annually through customer retention because of personalization and recommendation efforts. So they will continue to do this because they can retain customers, because customers like the fact that they are being handled like almost personally, although it's just a sort of AI engine that is doing it. It's not human, so it's AI engine. But still, you feel that you are being treated personally. Okay, so this is the beauty of artificial intelligence. Yeah. Okay, I think we've gone that. A bit on AI, very, very fast. Okay, this is the words of Bill Gates. Yeah, AI actually is a tool that is being developed to imitate human intelligence. You and I, we are human, we are very intelligent. So AI is about imitating our intelligence so that the machine can make decisions. The machine can provide basic reasoning. I should have closed my Wi-Fi. And then, and also can use any other or imitate any other human characteristic. Okay, basically if we look at our own capability, human, we can reason, yeah, we can recognize, you can recognize your friends, yeah, if I see you once, I can recognize Dr. Zila, yeah. So you can perceive, you can learn, you can acquire information, you can relate, yeah, and also you can recall, yeah, what you have seen previously, you can recall, and you can adapt to the situation, and also you can generalize. For example, you see one species of fish, and you see another species of fish, you know that is a fish. You won't say that is a dog or cat. You know that is a fish, yeah. And you can make decisions. So these are the capabilities of human. And this is what the machines or AI machine wants to do. It wants to imitate us. Yeah? It wants to do. But because of the capability of computers, they can do it faster than us. They can do computations faster than any human being. So that's why they are powerful. They can have all our abilities, capabilities, plus extra capabilities in terms of computation, in terms of doing churning numbers, in terms of making statistics information, statistical informations of the data that they have. For us, it will be very, very slow, difficult. So like this, as I mentioned, fish. So you know there's a fish, there's a dog or cat, or for that matter. So we want to train the AI to know this as well, recognizing patterns. Yeah. So human can recognize patterns. We know flowers, we know animals, and things like that. So the idea is to also train the machines, yeah, to do this, and we can use AI techniques such as neural network to recognize patterns. Neural network is basically very good at recognizing patterns. Handwritings, for example, yeah. For us, it's easy to recognize the writing's intelligence. For machines, we have to train the machines to understand that this is the word intelligence. It's not that easy, but there are methods using AI technology and other image processing and so on, pattern recognition. We can make the AI, the machine, to understand, even if you write in any way slanted, small or big letters and so on, we can train the machine to understand. Okay, AI and machine learning, basically machine learning is a subset of AI, and deep learning is the subset of machine learning as well as AI. Deep learning, basically it is artificial neural network, but composed of many layers. So it is very deep layers. It can learn a lot of things. When we give data, it can self-learn. Okay, so very, very powerful technique for learning. Okay, basically if you look at some of the applications, for example, the computer architectures is copied from our brain, yeah. And then the aeroplane copied from the birds. And then the robots basically is copied from our anatomy of the hands, legs, and so on. And the thumbprint, they turn it into barcode. So all copy from the biological system. Okay, and in the 1990s, it's about decision making. They use a lot of fuzzy logic. So again, that is the way the human make decisions. And these are some of the techniques of AI that I'm doing at Cairo. Genetic algorithm, basically for optimization. Neural network, definitely for pattern recognition learning. And now we are using a lot on deep learning because this gives a very powerful learning algorithm and so on. Okay, I'm going to skip this. Time is really not... So if you see, artificial intelligence is really going up. Yeah, going up. From 2012 until present is going up, and it will be going up forever. And US is the leading artificial intelligence applicator. So they have more than 2,000 companies in the US, followed by China. And the talents, artificial intelligence talents, we are short of talents in Malaysia. So we want more AI talents in Malaysia. So probably, you know, if you want to brush up your skills, maybe you can look into AI. So in the US has the most number of talents in the US, 850,000. Followed by India. India is very good with software, so they have very good AI talents, and UK and so on. We are not in the top 10, so we have to move very fast to increase our talents. And as we have seen through my talk, whether Industrial Revolution 4.0 or as AI is central to that technology or revolution, is it a blessing or a curse? Yeah. So we have, this is based on the survey of 2,000 adults in Great Britain in 2016. So about 26% of this adult mistrust the AI technology. About 18% is accepting the technology. 13% feel powerless, yeah, against this rise of AI. 20% are very excited. Okay, 22% optimistic. Frightened, about 11%. Skeptical, 32%. Anxious, 19%. Indifferent, 14%. Inspired, 13%. But whatever you feel, what my message here is, whatever you feel, you cannot run away from artificial intelligence because it will dominate the industries, it will dominate your life also. Okay, so these are some of the features. I will skip this. I want to show you one video. This one.
A technology straight from science fiction. The first cyborg. A wearable robot where machine and human merge to do the impossible. Japanese company Cyberdyne is transforming light with a robot named Hal.
We developed the world first cyborg robot, and this robot is controlled by the human's intentions from the brain.
Hal reads brain signals through sensors on the skin to understand how the user wants to move. For some wheelchair users, this has meant the ability to walk again. Robots like Hal can also give ordinary people, like nurses, construction workers, and emergency rescue teams, super strength. The lumbar support and mechanical power help people lift weights far beyond their natural capacity. Hal is a personal care robot designed to interact with people in their daily lives, but creating something new has its challenges.